Okay, this video tutorial looks at the mathematical strand of geometry, and more specifically, we're going to focus on our understanding of some circle geometry theorems. So before we look at some of the theorems, it's really important that you have a fair understanding of the different parts of the circle. Okay, so when we refer to these different parts, you'll understand what we're talking about. So what I'd encourage you to do is to just pause the video here and maybe take some notes on the different parts, okay, and maybe a description of those, okay, especially things such as chords, okay, radius and diameter you'll need to know, circumference is really important, arc, sector, and tangent are some things that we're really going to focus on in these next few theorems. So the first circle theorem that we're going to look at states that the angle in a semicircle is always going to be a right angle. Now we know that a right angle is equal to 90 degrees. So this angle is formed when an angle is drawn to the circumference. So remember, the circumference is this line around here. Okay, and it's from the endpoints to the diameter. So if we're looking at the diameter being this orange circle, orange line, when we make that into a triangle, okay, the point that's made on the circumference is always going to be 90 degrees, or a right angle. Okay, so the second theorem we're going to look at is chords in a circle. Now, you will remember that from our previous slides that the chord is a line that passes through a circle, okay, that doesn't go through the radius, through the center. All right, but when you have a radius that meets a chord at right angles, as pictured here, okay, so in red is our radius, okay, the chord can be in blue. Okay, that's the line that's going through the circle. And obviously that's going to meet at right angles here. Okay, that means that it actually bisects the chord. So the radius actually bisects the chord. Bisect means that these become the same length. All right. And conversely, it's important that if a chord is bisected, it means that it's met another line or another chord or another radius at 90 degrees. Okay, so it's really important that if they meet at 90 degrees, it means the chord is bisected. If the chord is bisected, then where those lines meet must be 90 degrees. So the third theorem that we're going to look at is called the radius tangent theorem. Now the radius tangent theorem, remember that the radius is from the center of the circle to the circumference. I've just drawn it in red. And a tangent is a line that touches the circumference of a circle but doesn't pass through it. All right, so if a radius meets a tangent at the circumference of a circle, then the point that they meet is going to form a right angle, and we know that it's 90 degrees. Okay, so remember that when a tangent meets a radius at the circumference of a circle, it's going to be a 90-degree angle formed. Now, the last theorem that we are going to look at in this video tutorial is the fact that when two tangents are drawn from an external point and they both meet the circumference of the same circle, then the lengths of those two tangents must be equal. So if we're looking at our diagram here, we've gone from P to A. So P is our external point here, and A is where that tangent meets the circumference. We've also got the tangent of BP, or from P to B. And we know that because they are from the same external point, then those two lengths must be the same. Now we're going to answer some practice questions here. Please feel free to pause the video. Every one of these is based on one of the theorems we've just gone through. And you just need to tell me what the unknown variable is. Look, if you know the reasons why, that's even better. Okay, but please feel free to pause the video, and once you think you've got the correct answers, continue the video and we'll see how you went. So in our first question, so question A, we're looking at the theorem, the fourth theorem that we just looked at, where we have the external point, okay, and we have both tangents running off, all right, and we know that when two tangents are drawn from an external point, they are in fact the same length, so therefore x is going to equal 5. In our second question here, we're talking about the radius and the chord theorem. So when a radius meets a chord at 90 degrees, and we can see that there's a 90-degree angle here, it means that it bisects the chord. So that means that x, and it looks like 3.3, it might also be 33, but we'll go with 3.3, must be the same. So x must be 3.3. In our third question here, we're looking at the radius tangent theorem. And we know that a radius meets a tangent, so this part of the triangle is our tangent. And the radius is obviously from the center out. All right, we know that that meets at 90 degrees. So therefore we must say x is equal to 90 degrees. And our last question, that was looking at our first theorem, like angles in a semicircle. We know that the angle created in a semicircle is a right angle. Therefore, we can say this is 90 degrees. We've got 38, and therefore x must equal 180. Take the sum of 90 and 38. Now, 90 and 38 is equal to 128. So 180 take 128 is going to be equal to 52 degrees.